How's it going? This is Abhijit here, and welcome to DevOps Challenge Hub. So today, let's go through the most important terminologies or terms in SonarQube, which are frequently asked in interviews. So I have already set up this SonarQube on EC2 machine, EC2 instance. So let's go through the terms one by one. The first one is code smell. So what is code smell? So code smell is not a bug. Have a look at code smell. Go to issues. So intentionally, I have written a Python code where I tried to have all types of issues like a hard-coded password, code smell, and then some maintainability issue, bug, all these issues. So you can see that we have vulnerability, we have code smell. So change this argument, function len expects a different type. Then refactor this function to reduce its cognitive complexity from 26 to 15 brain overload. This code smell is a bad practice error handling. This is unused variable. This code smell unused variable. So what is code smell? Code smell is not a bug. It's code that works but is poorly designed or difficult to maintain. So it's poorly designed. It's not written badly. So smell is coming, right? Like bad smell is coming from the code. So code smell. Uh, so it is working fine, but it's difficult to maintain. So for example, if you see that it has A, B, C, and let's say variable naming conventions are not proper. Then let's say you have 500 lines here. If this function process has 500 lines, here it's only 3 or 4 lines, it's fine. But if it is having 500 lines and 20 different variables A, B, C, then you won't be able to figure it out what is happening, right? If variable name is proper, then you will be able to understand, able to follow the code, able to, if someone is going to maintain this code, it will be easier for him. So this is hard to maintain if there are 500 lines of code here. So SonarQube will report a code smell issue. Next one is bug. Bug is a code which will produce incorrect behavior. So for example, if you look at this code, here's name equal to null, and we are trying to print this name dot length. So it will give null pointer exception, right? This is a null variable. So null pointer exception you will get. So SonarQube identifies this as a potential bug. Here also we can see, I think, a couple of bugs are here on the dashboard. Code smell bug. Delete this unreachable code or refactor the code to make it reachable. So some part of the code is not reachable, it will be never get executed. Next one is vulnerability. Vulnerability is a security weakness in the code. Hacker may take advantage of that code and execute some malicious code and try to get access to the system. So, for example, if you look at the string query, select start from users where ID equal to this plus user input. So, user can input like a user input is there. So, SQL injection may happen. So, attacker may enter 1 or 1 equal to 1, and user may try to inject uh, some malicious code which was not supposed to come here. SonarQube will flag this as a vulnerability. It's a security risk. What is security hotspot? It is a common question. What is the difference between the security hotspot and vulnerability? Security hotspot is not necessarily a vulnerability. It requires manual review. So it may be risky. SonarQube is not sure, but SonarQube is asking you just review it once. So here request get parameter PWD and so SonarQube will say please review this code for security reason. And developer will decide whether he wants to keep it, whether it's safe or not. So SonarQube is thinking it's something fishy, but it's not sure. Vulnerability means it knows for sure that it's a risky code. Technical debt. What is technical debt? Technical debt is estimated effort required to fix the issue. So sometimes, like, what happens that due to a delivery pressure, deadline, uh, people write code which are not well maintained, or people take shortcut. So they make some compromise. That may introduce some bugs, or that may introduce some issue that has to be fixed later. So that is called a technical debt. Effort required to fix the issue. Effort required to fix that issue. That's basically technical debt. Quality gate. It's a set of pass-fail situation. Like, for example, quality gate. Uh, if code coverage, like report is 70%, I will fail the build. If coverage is greater than 80%, then only I will pass. Bug should be zero, vulnerability should be zero. If there is a single vulnerability also, I'm going to fail the build. It's not going to be merged, or it's not going to be pushed to the next environment, etc. Right? So pass fail factor will be decided on that. The quality gate, let's go to the SonarQube dashboard. Here you can see issues, rules, quality profile, quality gate. So they are the common questions. What are rules? What is quality profile? What is quality gate? Right? So quality gate, already some gate is created. New code should have zero issues. All new security hotspots are removed. So this is the quality gate, and then we can also create a new quality gate. Test quality gate and create, and then here you can see that if issues greater than 5, or security hotspot removed is if this coverage is less than 80% or 70% or whatever you want to keep. So you can set up your quality gate. You can add conditions also, and based on that, pass fail will be happening. So this is the quality gate which we set on the SonarQube dashboard. Then quality profile. Quality profile is a collection of rules, like question paper, right? Collection of question. Quality profile is a collection of rules. So if I go to the dashboard, go to rules, where you have a lot of rules up there. There is, I think, for Python. Uh, for example, not this is not the this is not for size. Let's see. Like this is ampersand, and this thing should not be used. This pipe should not be used. This is a code smell minor. PHP, for PHP it's a subspecies. So this is for Java. This is also for PHP. This is for CSS. This is in here. This is obsolete. It should not be used to test inability. In Python should not be used. So this is a code smell major. So there are the rules, and here we have the quality profiles. It's a set of rules. So we have different profiles for different language, etc. HTML, CSS, Java, JavaScript, Kotlin, Kubernetes, Python. There are 305 rules. So these are all rules of the Python, right? Greater than, less than should not be used to test inability. Python. This has become obsolete. You should not use this. But iter should not return iterator. This is Python 3. Okay? Obsolete, pitfall, async, AWS. But there are many rules out there, unused, design related, typing related. So there are many rules out there. Collection of rules is basically quality profile. And quality profiles, there are several quality profiles for different languages. Quality profile is collection of rules used during analysis. So Java quality profile, no unused variable, no duplicate code, no hard coded password. These are individual rules. And you can customize these rules. You can add, you can delete, you can modify. So the interview question can be like, have you customized any SonarQube rules? What rules you have customized? Okay? The next question is coverage. Next concept. So percentage of code executed by the test. So, for example, let's say coverage. Okay, let's have there's some code like this. If uh, a greater than 100, then do this. Otherwise, do something. Right? Else execute something else. Now, if I test at 100, 200, let's say always it will be executed. It's just example. It will be always a plus b, but for some thing, let's say it's not add function, some extra thing, right? So here, if I pass 100, always this part of the code will be executed. Else part will never get executed. Let's say I have test which is passing this to 100, 300. So that means maybe 101, 300. So it will be always this part of the code will be executed. This is let's say 101 because I said greater than. This is 102. So when 101, 102 means always this part of the code will be executed, the other part won't be executed. So how do we catch that? Whether my test is executing everything or not? So to catch that, I need to have code coverage. The code coverage tool will tell that whatever test you are doing, it's not covering the complete block of the code. Whatever else part, it's not getting covered. So code coverage means tell that from that code coverage report you put in the uh, SonarQube, and SonarQube you can decide whether to fail or pass the build. So the unit test exists and it's a article 5, add 2, 3, something like that. And coverage may be 100%. Duplicate code, same logic copied multiple times. So I have that app.py Python file and I'm writing some code 10 lines. Again, that 10 lines I'm copying somewhere else. So it's a like maintenance will be a problem. So that is a duplicate code. Repeated many times. Uh, so idea is to use a function and call that function in different time. So SonarQube will report duplicate percentage. Maintainability rating measures how maintainable the code is. If it is A, it's excellent. If it is E, it's a very poor. That will give you some rating. How maintainable your code is. Based mainly on code smells and technical way. Based on these two factors, it will decide how maintainable your code is. Reliability rating measures risk of bugs. Based on the bugs, it will measure the risk. D means like if many bugs exist, it will be D. Security rating, no vulnerability is A. Severe vulnerability is D. Right? Security rating measures security out. New code. So suppose you have old code database and there are like 2000 bugs in there. So 2000 at one point, like you cannot fix all 2000 bugs. So what generally people will do, like they will focus only on the new code. In the new code, they should not introduce new features. And clean as you go, and then maybe you you don't introduce new bugs in new code, and old bugs also slowly you keep cleaning. Like all the 1000 bugs at one shot you cannot remove. Slowly you can remove. For example, there are 1000 lines existing, 100 new lines added. So Sonar will focus only on this 100 new lines. So that's a new code. You can on the dashboard, Sonar to dashboard, you can give that instruction about quality code, quality gate also you can give that instruction, fix issues in new code first, like focus only on new code. No error should be in the new code. There should be zero errors in the new code. Leak period, it's an older term. And now we use new code. Sonar scanner. This is basically a tool that performs analysis. So when you check out the code, it GitHub creates a runner, it's a Ubuntu machine where it takes out the code, builds it, run the Sonar scanner. It runs the scanner and collects the data from the file and sends that data to the SonarQube server. So the scanner is running on the same build machine where the build is happening or where the checkout is happening. Scanner sends results to SonarQube server. That is Sonar scanner. SonarQube server, you know that is a central server where reports are stored. It can be your own machine, EC2 machine where you have installed SonarQube server, or it can be Sonar Cloud. You have taken software as a service, you have created an account, and you got all the token details, URL details, and in that server, which is not hosted by you, which is hosted by Sonar Cloud, and you're using that. So you don't have any maintenance issue. Otherwise, if you are setting up your own server, you have to maintain it, manage the disk space, PostgreSQL maintenance, version update, etc. All this we have to take care of. Sonar token why token is needed because GitHub has to communicate with the SonarQube server because GitHub is running this scanner. Scanner has to upload that data to the SonarQube server. So it needs that authentication. Authentication will be done using Sonar token. Branch analysis. So for separate branch, you can run the Sonar scanner. Main branch, you can run Sonar scanner. Then you push on your feature branch, you can say that when it is pushed on feature branch, I want to run Sonar scanner. So you can analyze different branches separately because bugs are also different. Different developers are working on it. So main, develop, feature, login, and each branch gets its own report. Pull request analysis to check code before merging. So developer creates a pull request. So he develops something and he wants to merge. So he creates a pull request. As soon as he creates a pull request, GitHub action runs and it runs the Sonar scanner, which analyzes and see whether he has introduced any new issues or not. Right? And based on that, decision will be taken. It will be merged or not. And sometimes like that details you can push to pull request itself. So it's called peer decoration. Called peer decoration. And the pull request itself will be able to see what are the issues happened. You don't need to come to SonarQube server. And the GitHub pull request itself will be able to see. So SonarQube will get the results and it will push back to pull request and it's called peer decoration. Issue severity. It classifies issues, blocker, critical, major, minor, etc. Right? And you have seen that in the dashboard. Okay. We have blocker, major, blocker. So that's it. That's it for today. Hope you like this video. Please like, share, and subscribe. And see you again in the next video.